All right, number 9. So this one is asking us to take some more integrals. No, actually, this is our first integral. So we're taking some integrals, and we're starting with integral from 0 to 1 of dt over 4 minus 3t. So I look at this and I say I have like 1 over t is kind of what it looks like. And so that's making me think this is probably a natural log. So I'm going to try to make it 1 over t. So let's let u be equal to 4 minus 3t. So then du is derivative of 4 minus 3t is minus 3 dx dt. So dt is du divided by minus 3. Okay, not too bad so far. Also, I've got these bounds here, so I want to go ahead and change those. U of 1 is 4 minus 3 times 1, which is 1. U of 0 is 4 minus 3 times 0 is 4. So I get this is integral from 1 on top, 4 on bottom, right? So you might want to be careful. You might feel compelled to put the 4 on top and the 1 on bottom, but that's not what happens here. And then we get du over minus 3 for minus 3 times u, replacing it with the dt and 4 minus 3t with the u. So this is 1 over minus 3, integral 4 to 1, du over u. And it's fine to integrate it from here, but I really don't like the bounds being wrong like that. So I'm going to change this to minus 1 over minus 3, integral 1 to 4, du over u. So from Cal 1, we know that if we want to flip our bounds, put the top bound on bottom and vice versa, we can do that. We just have to slap on a minus sign. So that's what I've done here. So this is 1/3 log of u evaluated 1 to 4. Since I changed my bounds, I don't go back. So this is 1/3 log of 4 minus log of 1. All right, seems reasonable enough. Log of 1 is 0, so that goes away. And we're left with our final answer, which is 1/3 natural log of 4. And that is that first integral. Part B. Integral e to the sine x times cosine of x dx. So here we've got a similar idea. Okay, so what am I thinking? I see integral of e to the something, so I'm kind of hoping I can just turn it into that. I see a sine of x, and I see a cosine of x. Sine of x is trapped inside, but cosine is being multiplied, so I'm thinking I need a u substitution here. So let's do that. Let u be equal to sine x. Du derivative of sine x is cosine of x dx. So this integral just becomes integral e to the u, cosine x dx, that's perfectly du. And so I get this integral is e to the u plus c. But now I go back and plug in what was u. So this is e to the sine of x plus c. Okay. And then one more. C. I'm taking the integral of 3x squared e to the x cubed dx. All right, 3x squared, e to the x cubed. So initially I see x squared stuff and x cubed stuff. So my u substitution senses are tingling. And looking at it, if I do that, I'm going to have integral e to the u. So let's make that substitution. U equal to x cubed. Du is 3x squared dx. All right. Again, if you're having trouble with u substitution, the best thing I can say is practice and experiment with making things u. And if you can get rid of all the x stuff, then 90% of the time you did it right. Okay. So now we have a 3x squared and a dx like we do over here. So I can just have du, and I have e to the u du, which again is e to the u plus c. And then I go back and plug in, this is e to the, x cubed plus c. So a not unreasonable u substitution. And that finishes it up for problem number 9.